Good evening, everyone. My name is Paul Suazo, and this evening I'm going to briefly present on my research protocol for our networks class. You might remember at the beginning of the course in my intro video, I spoke about being a staff person, an analyst in our strategic plan team at the University of Colorado, Denver. And I've been involved in supporting the development of uh, a metrics system, performance management system, and then efforts to connect all the various areas of work that happen on the university to that system. And so a project that I decided to move forward with was mapping our research enterprise, our research system on campus, and then connecting that to our budding metric system for performance. And when I started this course, I was considering, how many different networks or areas of interest I could follow in developing the project for this course. But it became clear that the area that would be most fruitful would be to develop a network of the research system on campus so that I could later connect it to that metric system. And in the past few weeks, let me back up a bit. Last summer, I helped organize a community of practice for a project that we did around the use of AI on campus. So designing a strategic approach to trying to keep up with how rapidly AI is evolving so that instead of responding to the changes, we are being proactive in terms of policy development, use cases, identification of tools. And one of the areas that we noticed in launching that project around large language models is that a lot of people on campus a lot of staff and faculty are not uh, they're not using AI, or if they're using AI, they're using lots of different tools. There's a lot of misunderstanding and trepidation around AI. So we launched a community of practice to address as many of those things as we could over the course of the summer. And as I was working through the project for this course, I began thinking that communities of practice are about knowledge transference, and knowledge transference leads to new ways of doing work, new ways of thinking about things. In other words, innovation. And if we could think of innovation as an emergent property of an operational system, like our research system on campus, how could we further our performance or improve our performance by engendering increased innovation? And so I decided to think of communities of practice as methods to increase knowledge flow in networks and in complex systems, and then see how they affect performance. So that's what I'll be presenting on this evening. My research question is, can communities of practice improve innovation, enhance performance in the University of Colorado Denver's research system? Very quickly, my protocol overview. I'm going to model individuals, staff and faculty in research-related jobs as a directed binary social network. And I'll talk more about the nodes, the individuals, and the edges in the following slide. And then I want to test the hypothesis that is mentioned in the research question, that communities of practice can improve performance by increasing knowledge transfer. I'm going to begin, the research plan is to identify the key local measures, identify key global measures, betweenness distribution being an important one, because betweenness it doesn't it helps identify those nodes that are central to information flow or collaboration or all the sorts of things that are important to the movement of knowledge between individuals. And then, part of the research plan is to detect communities through, global clustering measurements, and then conduct local measures in those communities to determine the influence of communities of practice on knowledge transfer. So the network type, it is a binary directed social network with attributes. I've included, when I first started this project, I thought about doing a bipartite network. So you could look at, one layer of nodes or one layer of a network where the nodes are all the individuals and the relationships to each other, and then how they relate as members of groups, so members of communities of practice. And that would provide, a useful way of looking at this system. But I thought that maybe attaching attributes, one of which would be participation in a community of practice, so a binary attribute, yes or no, might offer a more fruitful way of looking at the network. So the nodes, like I mentioned, are individuals in research-related roles. The attributes that I include in this study are job title, the area of work, so that could be like contracts administration, it could be actual research that a faculty member does, and then of course, as I mentioned, community of practice participation. There are lots of other attributes that could provide really interesting or important information, and they could be utilized for a second phase of this study or even a second study at some point. But some of those other attributes might be, area of expertise. So what individual, what node in the network has a certain area of expertise? And are they participating in a community of practice? And if they are, is that expertise flowing out through the rest of the network? If they aren't, then obviously that knowledge, that information is sort of staying with that one individual. Um, so, that has important implications for thinking through how to improve performance. How do we get buy-in from those individuals and then maybe create structured learning, a community of practice or something else to engage them to pass their knowledge on to other individuals in the research system. And then the edges are directed binary links that represent the knowledge provided from one individual to another. So A, you know, professor provided knowledge to B, staff member, or, could be the other way around. So I selected a binary directed social network because it captures the directional flow of knowledge, which is pretty important for thinking through how performance or measuring even performance at some point within the research enterprise. Okay. So the local network measures, they are a lot about centrality with clustering coefficient there. But in degree and out degree centrality, betweenness centrality, page rank centrality, closeness centrality, and clustering coefficient. So these measures help identify individuals who are really central to knowledge transfer. And that's why they're all really related to centrality. We need to know those individuals who have the information and where they sit within the network so we can determine how to move that information and spread it out through the network. So the in-out degree centrality indicates who gives and receives the most knowledge. The hypothesis that I stated earlier predicts that community of practice participation would increase in degree and out degree centrality. Like I mentioned earlier, betweenness identifies those individuals who coordinate information flows. They sort of sit in the center of things. And it's important for understanding innovation and collaboration across different groups within the network, that measure. PageRank shows who is connected to influential other individuals. I selected PageRank over eigenvector centrality because of the directed nature of the network. And then I chose PageRank over CATS centrality because I wanted to make sure that the individuals who might be connected to other individuals with high CAT centrality weren't passing that high measure on to the individuals that they had an out connection to. And that could be, if you think about management teams, they might all together have high CAT centralities, and they would then pass it on to other individuals that perhaps were direct reports. we don't want those CAT centralities from, someone on a management team who isn't your direct supervisor being passed on to you, because we want to measure the knowledge transfer that happens within your team, within clusters in the network. Closeness offers information. It provides information into how quickly a person can access knowledge from others. And then clustering helps reveal whether communities of practice coincide with other groups within the network, other knowledge sharing groups. It could be areas of work. So that would be individuals who might share similar responsibilities. Okay. And then the global measures, the distributed network, degree distribution, betweenness distribution, clustering coefficient, and closeness distribution. I'm going to go very quickly because I'm kind of, my presentation is going long here. But so degree distribution can reveal hubs or bottlenecks in the research system. It can, like I mentioned earlier, if there's someone who has a great deal of knowledge, and perhaps they have a high in degree, but not a high out degree, that knowledge that they have might not be passed on to others. So there's a bottleneck in the research processes in the research system. And then the betweenness distribution highlights how many individuals occupy the central roles, the roles where information flows through. And this is useful for interpreting organizational changes. So we are making a lot of changes in our organization across all the core functions: teaching and learning, research, administration, and operations. I'm not really thinking of this as looking at a time series, but if we take a snapshot of the research enterprise now and the betweenness distribution now, it can help us show where things are now versus where they might have been before. And then clustering, it just shows whether tight clusters exist beyond chance, and it indicates potential COP, community of practice clusters. Oops. And then, yeah, my last slide. So implementation challenges and then the null model. So I think the biggest one is data collection. So this would be reliant on qualitative data collection, which could be surveys, structured interviews. How are we figuring out who is passing knowledge on to whom? There isn't really a structured way to do that currently. And then following from that, what is the accuracy of the edges? Do we have all the information we need to determine that the edges are fully accurate in terms of who is passing knowledge onto whom? The hierarchical clustering, I have some worries about its ability to detect communities and how does that overlay with communities of practice. The analysis that I presented here is heavily degree centered. I think that makes sense with what I'm looking at, but are there other things that I could be missing or that the data might not be able to provide? And then the null model, I think the best one for this project is an exponential random graph model that preserves key structural features of my model in building a comparative null model. And it allows to test whether, like all the null models, whether observed patterns arise by chance or random. And importantly, it's suitable for organizational networks. So that is a brief introduction to my project, and I thank you for your time.